So if you go to our website, you'll see we've open source software that we've made available to the public for this. Essentially what it does is it interfaces deep reinforcement learning libraries with essentially two micro-simulator tools we have, Sumo and IMSUN, and it all runs on AWS or your favorite cloud, doesn't matter. I think when we did it, it was probably one of the few, if not the first framework to do it. In fact, IMSUN did have its first cloud-compatible implementation of IMSUN for us. It was for the connected corridors. So at the time, it was really new. And then Sumo obviously was a lot more amenable to that because of the way it was built. I think now it's pretty much, kind of a state of the art, but I think we'd still make that available. So if you're interested in playing with this, there's a few startup cases and papers that explain how to do it. So if you're interested in using that software, you can do it. I mean, it's kind of Lego blocks. Bring in your Sumo network, and then train it, and then build on it based on what you have. One of the aspirations we had was to also create a dashboard. We turn it off now, but we're going to turn it off again, turn it on again later. So for those of you who do robotics, you probably are familiar with Mujoko, which is what you see on the right. So Mujoko is this kind of World Olympics, if you will, of robotics for any basic, system you can think of. So like a exoskeleton or spider or ant, or like there's a bunch of benchmark problems. And essentially, the beauty of it is that when you check in your algorithm, you can benchmark yourself against the rest of the community because these are become benchmarks. So the idea is we're going to do something similar with energy for traffic, and that's something we initially published at Coral. What we're building now for the US Department of Energy is essentially a whole pipeline where we have a leaderboard. It's not accessible to the public, but we hopefully will have it live in a few months. So if you're interested, we're very happy to work with you. So the idea is, again, you have calibrated models of specific freeways, and you can check in algorithms and compare them against each other. And so that's what that dashboard looks like if you look at it from the inside. So on the horizontal axis is the date, and then on the vertical axis is the score, and you can see algorithms improving over time. And every time you check in an algorithm, it will show you a bunch of things on how it's doing on that particular scenario. We also have done some workshops and or once in a while doing tutorials. So if you're interested, we can train you. And also, I just want to showcase the team here. It's not just Berkeley. I mean, it's a fairly large team. There's about 50 people now. So the headquarters are at Berkeley, but the test beds are in Vanderbilt. And we work very closely with Toyota, GM, and Nissan now. So and the Tennessee Department of Transportation. So it's a multi-faceted team, which includes anything from AI to essentially hardware development. So for example, at University of Arizona, John Sprinkle, who is also in the program, has developed a LeapPanda-based Comma AI implementation pathline that takes our policies and essentially migrates them to ROS, so we can experiment with them directly. And that's kind of the way it looks like. So for example, he has, oops, sorry for that. So he has a way to already remote drive the car. And this summer in Nashville, Tennessee, will be able to experiment it in the field. And this is the test bed that Dan Work is now developing with TDOT, the Tennessee Department of Transportation, and that's going to be really our test bed. And so there, what you see is a instrumented set of the freeway. They're deploying one pole, like the ones you see here, every 500 meters. So this is the first 3 poles when they deployed them. And then I think there's a $12 million investment from the Tennessee Department of Transportation to instrument the rest of the I-24 freeway. And so Vanderbilt is very actively involved in erecting these poles. You can see the first pole being erected right now as I speak. And essentially each of these poles has a 6-pack video camera system that will give us very high fidelity recordings of all the things I'm showing. So you can see with this pixel learning business I showed earlier, I think there is a lot of hope that one day one could use that also to operate that freeway. And this is the first pole of that project that I'm showing here. If you're interested in downloading the software, go to this URL, flow-project.github.io. It's all open source, so you should be able to download it easily. And then, of course, if you're interested about the Circles project as a consortium, or if you're an automaker or an industry startup, or even have interest period as an academic, go and contact us. We're on 5 campuses already, and we plan to grow that community even further in the future.